Hi guys, my name is Rakesh and I'm the studio manager. We are in Brunel Design School and the course that I work for is digital media. We have two undergraduate courses. We have digital design and visual effects and motion graphics, and an MSc course which is digital design and branding as well. Now, this is the green screen. I'll show you a bit more in a minute. But before anything, I would like to show you one of our students, which is the most recent showreel, which contains student work from our MSc to our undergraduate courses. I hope you enjoy. So that was our 2021 showreel, and what I'll do is I will shift from my computer to my mobile phone, so then that should allow me to show you our green screen. I hope you guys can see me and hear me properly. Can somebody let me know if you guys can hear me and see me properly?
Yes, we can.
Super. So now I'll start showing you our green screen, and I'll start from the beginning. And let me rotate the camera. So obviously that's the main entrance, and as soon as you come in here, you can see Cintiqs connected to Mac computers, and these Cintiqs are all 4K, and you can use a pen here, and it's also touch screen, which allows students to work not only on Photoshop, but on Maya and Nuke and many other software. And this is also used in the industry. That's why we acquired them. And just to let you see a list of our softwares that we've got in this room here, they are all industry standard software that our students get to learn so that they can, straight after their graduation, they can start working in the industry. Now we've got our green screen that you can see from a wide view. It is a fairly big green screen compared to all academic institution that you've got in the UK. This is one of the biggest one that we have. We are very proud of it as well. At this moment, I've put these props here that was used in the filming for The Good Omens, which is a production of Amazon Prime and BBC as well. So they left this behind for us to use as we wish, and our students are really taking advantage of this for their projects. As you can see here, there's a bit of overhead lighting. Now these lighting, we use them to light mainly the green screen. And their job is to simply make sure that the green screen is evenly lit, just so that when we remove the green background, it is easy peasy, but it's not always straightforward. What we have here is a standard 3-point lighting where you've got the key light, backlight, and a fill light as well. This is simply so that we can get a realistic lighting for the setup that we've got here. And the camera that we are using at this stage for this live king, that I'll show you what it is in a minute, is a Sony FS7. This is a 4K camera. It also allows you to record in RAW format. And we've got a variety of lenses, which are Canon mounted lenses that allows you to use on the Sony camera. And this gives you a lot of versatility in terms of the type of shot that you want to create. Now, obviously, when you use this camera, you use this in a full manual mode, which is advised, and we teach our students how to use these. We've got 7 of these cameras, and we've got many DSLR Canon cameras as well. But our prized possession is definitely the Red Epic camera, which is a 5K cinema camera, and it records in RAW format. And this has been used to shoot the title sequence of The Good Omens on Amazon Prime. And by the way, the previous camera has been used on a couple of title sequences for BBC and ITV as well. We work with the industry so that we can, our students can get a lot of practice working on live projects, and we allow industry to come here and use our facility as well, so that they can credit us and we can have more exposure in the industry as well. And as you can see, the camera is sitting on a jib system, which allows any camera, which is the Red or the Sony or any other camera, to sit on, and it gives you a lot of comfort in moving very heavy camera. And you have to counterweight it in such a way that when you do that properly, just with the push of a finger, you can move the camera around, up and down, back and forth. And what we'll be doing now will be working with this setup, which is a Live King system. This software is called an ATEM software control, and is connected to the Blackmagic, which is the key that allows the input of the videos from the camera, and you can select a background of your choice. In this case, we're choosing a library here to try and match what we are recording there, which is the table, the chair, and the board. So the process is not quite straightforward, but for the purpose of this demonstration, I've had to make it seem seamless. So what you'll be seeing now is, if I show you the image of the library, and what I'll do is I will show you what you would normally see from the camera. And let me just show you how the final edit will look like once you key the green color out. The purpose is to put the camera, use the appropriate lens, appropriate distance from the background, and also using the same height as you would, and light it appropriately so that then you feed the information in this software here. And with a lot of tweak, and trust me, there's quite a bit of tweak that you need to understand what's working in the background so that you can come and have this final product here. Now, normally you would be able to have a couple of actors, if not more, to play in the scene here, and it would look seamless simply because the scene has been lit according to the background there. And if I can show you how this would normally look, without any mask and without any chroma key, that's the image that you will be normally seeing, which is you can see the overhead light, you can see a bit of the light on the side, but the keying process involves of removing all of this by creating an appropriate mask, which removes everything that is not wanted, and then create an appropriate keying as well, so that everything is blended in properly. Unfortunately, I don't have an actor to show you how it works, and I can't be my own actor and be filming the widescreen TV here. So you'll have to trust me that it works with an actor. Now, what I'll do is I'll rotate the camera for a second and see if you've got any questions. I'll be more than happy to talk about the green screen and what we do over here.
Yes, I've got a question, Rakesh. Is it possible to mix both virtual and physical objects in the final scene?
Absolutely.
Okay.
The whole point of the green screen is to be able to put any virtual background with a real background. Now, at the moment, obviously, you see a green background, but if you were to remove the green background and put a virtual background that you want your actor to interact with, for example, there was a desk here, or you didn't have this table, that was a virtual table. What you would normally do, you would put a green box, for example, of the same height, that wouldn't appear in the end, and the actor would interact with virtual, which is a non-existing prop. Was that your question, Abdul?
Yes, that's it. Thanks, Rakesh.
And with the new technology that is coming, what that is quite fast, and the industry is using these days, is virtual production sets as well, which is the latest technology. Now, instead of a green screen, we're moving forward, and hopefully we will too, where we use an LED panel in the back instead of the green screen, where we automatically projects what we would normally create afterwards as a 3D scene, whether it is the moon or Mars or the beach or wherever it is. You project that on the background LED panel. And then the advantage of that is that you don't need to key the green color. You automatically get the actor in the scene. They can see where they are, and the acting and the performance is better as well. And the lighting is more natural because you're getting the lighting from the beach or the moon or Mars or whichever planet you're shooting as well. Now, saying that, it is fair to say that the green screen will be around for the next 10, 15, 20, 30 years, who knows, simply because there's a good mix of virtual reality technology with the green screen that allows us to use what, Abdul, you're talking about, the virtual background, instantly with the green screen, with any camera movement that you have, and it replicates that instantly, and the actors can get a sense of the space as well by looking at themselves in a bigger screen like the one that I've just showed you. I don't know if that makes sense.
Yeah, I was more referring to the use of virtual objects such as avatars or characters which are synthetically generated.
Oh yeah, that has been done for many, many years. For example, if you have an avatar or you have, let's say, a dragon, for example, what you will have to do ultimately, you have to get an actor to dress up in green completely and have like a dragon head that is in green, painted in green as well. And the actor will interact with that dragon. And because of tracking system that you can put on the fake dragon, you can track that movement as well, and you can instantly generate a dragon that can be seen as a final result, like the one that I've just showed you.
Fantastic. Thanks, Rakesh.
You're welcome. Any more questions?
There's one from John. Fire off, John.
Yes. Hi. Apart from the using screens for backgrounds, as opposed to green screen type of approach, what other technologies do you think could be used to improve the these studio type systems?
Oh, absolutely. That's the one that I've just mentioned, which is the virtual production. So that basically replaces the green screen.
Yeah.
Instead of having a green screen, you actually have the background.
I know you explained that, but what I'm asking is, what other type of technologies could be used
Well,
to perhaps enhance the performance of a studio like the one that you're working in?
Well, the next level, which is already happening, is the use of different types of software. Like, for example, we have Unreal Engine, which is a major software in the games industry, but it has been adapted to work with virtual production. And what this does is not only allows you to get any type of background that you can put there, but it allows the camera to communicate with the background, with the LED background. For example, if you have a camera that has a specific type of lens, it will recognize that as well. And if the camera was focusing or defocusing, it will automatically send a message to the LED backdrop, and that image will change according to the focus, the camera distance, the camera panning and tilting, which are the camera movement as well. So there's a lot going on at the moment in the industry. And
yes, but what's going on in Brunel, if you see what I'm saying? That's more important to me. Yeah.
Well, what's going on at Brunel is we need to make it happen. We need to sit and we need money to make all of what industry is creating. We need to be able to not only replicate but make it better, and then we need to include that as part of our course. And what we are actively doing is we are using the dome, which is in the Michael Sterling building, or in between Michael Sterling and Wilfred Brown. And we're using the dome, and as from next year, we'll be teaching as well how to create content and project that on a 360 immersive dome. We've already done something. We've got a 360 camera, by the way, which films in 8K. We've already acquired footage, and we are working with people from the industry, which will be here on Friday for a soft launch, but you're all invited to the event, which is happening on the 31st of this month, which is next week. And from 2:30 to 4 o'clock, I believe, they'll be in the dome, and you can see what we are doing in terms of working with the industry. And also the project is all about synesthesia. We're showing how synesthetes, people who have synesthesia, sees the world. That will be a very interesting project for you guys to come and see. But yeah, in terms of what we can do here at Brunel, obviously it requires a lot of money, and the technology I'm talking about doesn't come cheap. We would love to make it happen here, and we are looking to get all the support we can, and especially you guys. If you put in a good word, I'm sure everybody will listen. Any more questions? I see there was a Eventbrite link that was sent, and please register your place for this event, and I'm sure you'll be pleasantly surprised. I'm hoping you guys have more questions. I see 2 notifications here. I'll just try and check on the phone if it works. And nope, I don't think that's for me. So I think I'm done here. Basically, it was a crash course on how to use the green screen. And if you want to know more, I'm in Tower C 005. Please pop in and ask any question you have. And by the way, I've got some good news. We will be having Peter Anderson's studio that will come here hopefully in June, July, and we'll be filming the next title sequence for Good Omens. It is in the pipeline. I don't want to jinx it, so let's hope that everything goes well and this will happen, where our students will get to work on this project, and I too get to work on the project as a DOP, Director of Photography. And it hasn't been confirmed, but BBC themselves will come sometime in June to shoot a shot from the BBC drama Silent Witness. So hopefully that will happen too, and you will see that obviously on our social media network and also on Brunel website when we will do it. Now, guys, if you don't have any more questions, I think that'll be me for today.
Thanks very much, Rakesh.
My pleasure.
This is as interesting as always. So thanks very much. We can move on to to the AI center. You can see both Luke and German are in the room. So do you guys want to take over? Hi, Luke. Hi.
Sorry, I have my mic off. Yeah, we'll take over. So for the AI lab work, we've got a short presentation, and then we'll move over to German, who'll give a demonstration of the project in the lab at the moment, and then we'll go for some questions after that.
Sounds great. Thanks. Off to you.
I'll start off with the presentation. So the project's called Revolt. It's motor condition monitoring and fault classification using artificial intelligence. So we have a few aims between us. The collection of data on motor operation in multiple domains, power, acoustics, and vibrations for both normal and anomalous operating conditions of the motors. So when it's operating as expected and when there are potential faults in the operation, we want to get all of that to kind of build our data set. And we want all of these normal and anomalous operating conditions under various loads and fault intensities to vary the data set as much as possible, and to ensure that we don't have an AI that can only detect certain points in fault data. So we want to log and classify all of the collected data that we have, and we want to build a data set from that for use in intelligent system development. So the end aim of the project is to design an intelligent system for detection and classification of faults in electric motors. So we've got a video demonstration, a current state of the project, signal processing and representations that we're generating, and then, as I said, the live demo and Q&A at the end of that. So first I will move to the video demonstration and let that play. So as you can see by the video, the main aims of the project are being followed by our current testing procedure. We're currently most of the way through. Oh, one sec, we have another member of the project joining. But yeah, we're most of the way through the data collection at the moment. We've collected data for normal operating conditions and a number of faults at all of the various loads and intensities that we've stated. And at the moment, we're looking at mechanical faults before moving on to more destructive damage to the motors, such as bearing faults, which once induced can't be fixed really. So yeah, we're getting to that point. So the physical systems, the test rig's design was designed by us at the very beginning of the project with the aims of producing something that we could test with safely and reliably. So we've designed it with a wide base and short legs to minimize the rotational force as the motor is running with the alternator. I think the maximum power for the motors is around 5 kilowatts. So while not as big as the megawatt motors that we're looking at in industry, they're still powerful enough to rotate smaller rigs, and obviously to minimize the risk to ourselves and the equipment. We wanted to make that as secure as possible. You can see on the bottom picture, the plates holding the motors in place. These are very thick steel plates that have been produced to support the motor without any risk of damage or bending, so that we can ensure that there's repeatability in the tests. And on top of those plates, we have much thinner plates that we use to provide height and align the motors with the alternator so that we don't have any misalignment in our normal data. The test rig's controlled by a cabinet provided by Volt Vision, the partner company of the project, and that handles both control of the motor, routing of power of the motor and alternator, allowing for us to induce loads, and also the recording of power signals. The signal processing, as I've said, the power signals are captured and recorded by the VoltVision cabinet in Comtrade format, which is an industry standard for fault detection in power systems. And that records the current and voltage values, power phases of the power signal from the motor and the alternator. That data is then passed to our local PC via Ethernet and transmitted over 5G to VoltVision's Azure database. The acoustic and vibration signals are recorded with industry standards recording equipment and processed using signal amplifiers, which are both connected to our computer. And currently we have the system of collection of data and storage fully automated, in that we can press a button, it will record the vibrations and acoustics and power, and those will all be stored in a database ready for us to use, ready for us to query for use at a later date. In the end, we plan to fully automate the classification process, integrating the generation of signal representations with the data acquisition, and passing the generated representations to our classification network for signal classification. This is kind of an overview of what I've just described. So we start with the motor operating the cabinet and the data acquisition systems, sample the data at appropriate frequencies. The data is then stored in an appropriate format, so WAV files for the acoustics, CSV for the vibrations, and as I've said, the Comtrade for power signals. We convert all of the data into CSV format for use in more systems. A lot of our data processing systems use MATLAB, which is very good at converting files, but it's simpler to have everything in the same format ready for use that we can just import, process, and move on. We then have the data processing system. We've named it Osiris. It's an optimized for signal representations for intelligent systems. At the moment, we're looking through our representations, doing literature reviews to work out what is the most efficient way of representing all of our data sets in a way that a neural network will be able to take it in, process all of it, and get a good accuracy without overloading it with too much data. We have conversions for the output of our data representations so that they're all again in the same format, ready to go into the classifier. And in the end, all we will be outputting is a note that says what fault we've classified the given signal at, and when the fault occurred. So we've now got a few examples of the signal processing representations. So the first thing we do is run a consistency check. So we're running up to 15 runs of any fault case. So we need to run through that and then check the data against each other to make sure that all of the test cases are similar with no anomalies within the fault data, because we want to know the signature for a fault, not the signature for an error in the recording. So once we've run the consistency checks, we compare the fault intensities to make sure there is some difference, to ensure that we're not wasting time by recording data for fault conditions that are very similar. We're working on signal subtraction at the moment to look at where the largest differences from the normal data and the fault data exist, so that we can minimize the amounts of data going through the network, hopefully increase performance, and as we've seen in other projects, potentially increase the performance of the network with regards to test accuracy. Obviously, it's not perfect, so when we are recording, there are points where we've noticed anomalies in our recordings, and of course, these have to then be repeated as we don't want faults in the supposed known recordings. This is just another demonstration of what problems the anomaly can have. So as you can see, the lower values are 4 of the normal fault recordings. However, where this spike has occurred, you can see it's completely changed the frequency spectra of that fault, meaning that that data can't be used, as it would change the neural network's identification of that fault. So that is a very quick overview of our project. I'll pass over to German now so that he can give a bit more of an in-depth look at the systems we're using, and then we'll go for questions. So I hope you enjoyed.
I hope you can hear me. Oh yeah, I will use my device. Let's see. Yes, now it should work. So I will just make a quick tour of our lab setup, and most of it you have already seen in the video demo, but just to have a live tour as well. So here it starts. Oh, this is the basic the system where we spend most of the time recording and collecting the data. Also do some processing work, and but mostly collecting and storing, receiving, and logging our progress. The electrical signals get stored here. This is the relay that you also saw. And this is the load. We have a load provided to the generator, so the motor can run under a load, which we generate from heaters by heating. And this goes to the motor. At the moment, we have a setup here to run electrical phase sagging tests by using a variable inductor. And we can switch off, we can switch, introduce the sagging by switching one of these switches, and the other one, since we have only one of these devices selected, the other one will cause a phase out fault. So it will completely disconnect one of the phases, because we are using a 3-phase motor and 3-phase system. This is the rig itself, the main rig. In a bit more detail, you see our instrumentation, which is the microphone here. You see the accelerometer there, the vibration sensor, which is a small cube, and the tachometer here, which is measuring the speed, the rotating speed of the motor by counting the number of times when the white stripe that you see on the coupling rotates and reflects back the light of the tachometer. Here it gets, these are the data acquisition systems, the analog to digital converters, which are then connected to the computer and provide the final data that we saw. Yes, so this was a quick overview. Can maybe switch back to here.
Here we go. And unmute. Thank you. So that's an overview of our project, and we welcome any questions from anyone.
It's worth to mention that this project, which you see, has been built since October last year. Design, implementation, connection of all instrumentations, planning of experimental data collections, overall data collection systems. All this has been done by our Brunel team here at Brunel. So we have basically built up the industrial scale, industrial scale test bed for high power motors that allow us to collect all variety of signals, from power signals to vibration and acoustic data, that will allow us to use in future in AI systems or in very controlled environment, and hopefully later on will be validated in real world systems.
That's interesting. So, guys, how do you decide that a particular point is an anomaly? Is it from the value of the error once you subtracted the signals from each other?
That's kind of what we're looking for at the moment. We're looking at the difference in the signals, seeing if it's clear enough. So we're inducing all the faults, so we know when a signal is normal and when a signal's faulty. What we're looking at the moment is what's the best way of representing data in order for a neural network to be able to determine that there is a fault in there. So signal subtraction is one method of doing it, looking at the frequency spectra, spectrograms, power distribution, different methods like that. We're looking into all of them and seeing, we're going to test and look at which ones are the most effective for our use cases. Yeah.
So I presume there would be like a threshold, an empirical threshold value beyond which you decide that there is an anomaly, and this is determined.
Most systems do it at the moment. It's just a given value, and if the power signal fall, or for most current signature analysis, it would be if it falls within a healthy range, the motor's okay. If it falls outside of it, there's a fault. Some systems can determine that. What we want to do is make a system that can determine degrees of faults. So we want to know if there's any early warning signs of a fault occurring. So we're combining our generated data set with field data from the partner company, VoltVision, to look at when a motor goes wrong, what occurred before that, and then can we classify our faults based on the signatures that they produce.
Right. Is there a plan to include a neural network that you teach us?
Yes.
Okay.
The end is to have an intelligent system, a neural network, process all of the data coming in from the field, and be able to classify based on what we've taught it, what signals occurred, or what fault has occurred, how far into the fault is it, and can we predict the remaining life on that particular motor?
Yeah.
Hope that answers.
Interesting.
What is important to say is that based on our signals we have recorded so far on the number of faults, there is no such thing as threshold above which we will be getting the values. Every single different type of faults, like electrical faults and mechanical faults, they have their own specific signatures that's not necessary having these particular threshold values that will be easier to catch up. So such type of systems like neural networks will help us to solve this far more efficiently rather than specifying threshold values and signals, because in many faults there is no such threshold identified.
Would I mean, excuse my question, but would image processing also help if you monitor?
Yes. So we're looking at image-based convolutional neural networks based on our representations we're generating in order to do the classification tasks. If you mean, say, using a camera to record the motors, we did have that idea, but we found that the vibration sensors, along with the high detail microphones and the power readings, are often more reliable. And we're looking at the system. The end goal for the system is to retrofit onto motors. So employing a camera on every motor in, say, a mine isn't going to be feasible. However, plugging in a small box that has a vibration sensor, a small microphone, and a power capture relay is a lot more doable than a high resolution camera that can track the small changes in vibration that fault would induce.
Makes sense. Okay, I asked many questions. Are there any other questions from the floor? So we've got a team of 3 good researchers there waiting for your questions. Go ahead. No? Okay, so this tells me that this is a sign of consent and approval. Well, thanks very much, guys. This has been really good.
Thank you.
Good luck with the rest of the project. A very interesting one. And well done, Tatiana. Okay, I think it's time to move on to the ideas demo. So John, you are in the room. Please take over.
Okay. Okay. Let's see. Oh, what I need to do is have the audio more generally accessible so that you can listen to it. Now, where's the thing that? Yeah, there it is. Yeah. Yeah. So this is I presented this earlier today, and I presented this earlier today. This is the first one. So this is our work in the building research establishment, and we went to building research establishment and we measured a whole load of things, and this is a video that was created from it. Building Research Establishment provides research, advice, training, testing, certification and standards for organisations in the UK and abroad. The Innovation Park at Watford site is open to the public and has welcomed over 2,000 visitors, including guests from the construction industry, local authorities, government, academia, school groups and international leaders. These visitors come to see the innovations in building technologies demonstration on the Bree Innovation Park. The increased use of wireless local area network communications in buildings is causing congestion and interference, whilst modern building materials are restricting the propagation of radio frequency waves within them. Therefore, building owners have been increasingly turning to the deployment of cellular home networks in their buildings because they operate in licensed spectrum and can avoid interference and congestion. The Innovation Park features full-scale demonstration buildings that have been developed by industry partners. These buildings display innovative design, materials and technologies which combine to address the development challenges facing regions across the world. Technology, demonstration, research, testing, training and dissemination are key activities which underpin the operation and development of the Innovation Park, making this the ideal place to demonstrate the Internet of Radio Light system in a home scenario in its famous Integer House, which has been showcasing new home technology for over 20 years. The Integer House was also built with a variety of intelligent home automation technologies and advanced communication technologies, such as a telephone service distributed via local building exchange, digital satellite and terrestrial television, web TV and closed-circuit television. The Internet of Radio Light project develops a safer, more secure, customizable and intelligent in-building network using millimeter wave and visible light communications. The conceived solution reliably delivers increased throughput greater than 10 gigabits per second from access points pervasively located within buildings. It does so whilst minimizing interference and electromagnetic exposure and providing location accuracy of less than 10 centimeters at the same time. Here we see two project researchers, Ben and Kareem, working in the house measuring performance of the 5G indoor system. So, for example, distribution of a 4K TV services can be provided throughout a home. Here you see video streaming to a 4K TV over a 5G VLC link being presented by two of the project researchers, Yui and John. When the 5G VLC signal from the communication LED is blocked, the TV stops playing, and when the 5G VLC signal no longer blocked, the TV resumes the streaming audio-video service. 5G remote radio light heads are pervasively located in 10 gigabit per second optically networked home, which distributes a 5G compliant multi-component carrier VLC and millimeter wave signal to each room from communication LEDs and millimeter wave antennas. A network home consists of an open-stack multi-access edge computing server, a layer 2 processor, a distributed radio access network providing a fully 5G compatible radio communications signal within Ethernet packets using a 10 gigabit per second Ethernet ring network to one remote radio light head controller per room and its 4 remote radio light heads in a parallel processing pipeline. The multi-access edge computing server consists of a software-defined network and a network function virtualization system which hosts virtual network functions that are used to provide network services. A security virtual network function sniffs packets to ascertain denial of service and rogue transmitter attacks. Local database virtual network function stores distant estimation data from the VLC received signal strength and the millimeter wave time difference of arrival measurements. The location server virtual network function processes this data to estimate the location of users in room environments. The multi-source streaming virtual network function transmits video streaming packets both through the 5G RAN and a lower resolution video through the Wi-Fi network to ensure service continuity. A load balancing virtual network function distributes load equally between the 5G RAN and the wireless LAN network. A 5G home network is able to stream 4K TV, 360-degree and conference call video, and support interactive multiplayer gaming. It is able to support location-based data access applications on smartphones or augmented reality headsets. Here you see video streaming to a 4K TV over a 5G VLC link being presented by Yui and John, with and without the presence of illumination LEDs. As you can see, the communication LED's performance is unhindered by the illumination LEDs, since video continues to be streamed even when the illumination LEDs have been turned on. The test receiver records 5G received signal strengths QAM constellation diagram, mean and probability distribution of the error vector magnitude, the error vector magnitude evolution with time, the block error rate and throughput for the physical downlink shared channel, the physical broadcast channel, and the physical downlink control channels. Here you can see the millimeter wave recording being taken at tabletop height 0.7 meters and the performance of the received physical downlink shared channel signal being recorded by Kareem, who is one of our researchers. Taking VLC measurements requires positioning the photodiode receiver on a grid, angling it towards a communication LED transmitter, and measuring performance on the test receiver. A 2 degree of freedom gimbal is used to rotate the VLC photodiode receiver towards a communication LED in order to maximize the received signal and hold it in a fixed position for measurement. Taking millimeter wave measurements requires choosing transmit angle, positioning the receiver on a grid, angling it towards a transmitter, and measuring performance on the test receiver. The 2 degree of freedom gimbal was enhanced to be able to do this autonomously. Results from VLC measurements show that the coverage has a diameter of 1 meter and a maximum propagation distance of 2 meters. Angling the receive LED improves the quality of the received signal. Received signal strength results have also been used to locate positions with a minimum location error of 3.5 centimeters and 80% of all location measurement errors of less than 10 centimeters. Results from millimeter wave 64 QAM transmissions have shown that for a transmit antenna pointing vertically down, the coverage area has a diameter of around 2 meters at ground level, with improved performance for measurements taken at tabletop level, 0.7 meters above ground, and with improved performance when the receiver is rotated towards a transmitter. Pointing the transmit antenna 30 degrees from the vertical, the coverage area can be better than 2 meters by 1.6 meters. The performance of the millimeter wave system slightly varied from one day to the next, and so is dependent on external factors which could not be identified. This project demonstrator has shown the viability of a 5G network home with just 4 mm wave radio heads required to provide sufficient coverage and location services for a family-sized sitting room. It has shown that VLC technology is a good personal area network solution, but requires its propagation distance and coverage areas to increase by a factor of 2 to make it commercially viable. The next thing we did was we were thrown out of that in February 2021.
Y equals 1,100. X equals 1,100. Y equals 1,200. Y equals 900. X equals 800.
Then that's what that led to this, which was a laboratory to that consists of Raspberry Pis connected to the wireless LAN, and then ultimately to an indoor 5G RAN. This is the next step, and
week we had a problem with the image that we downloaded from the OpenStack that we couldn't log into the image. We didn't have the password. We only knew the username but not the password. So we stayed for a while to figure out the password, and finally we were able to find it. So when we come to launch an instance, we put the instance name, the source, which is the source image that we want to upload. The flavor is how many CPUs, RAM, or the total disk you assign this flavors. Network, we pick the network that we're using, and then we figured out that if we go to the configuration files and we add a file that we made, which is called user data, it configures the image itself. So it sets the password to be password.
with the zero.
With a zero instead of a zero, of O. And that's it. We literally add this, and the key pair, we've already created a key pair. We can create one. We can import one if we have one ready anyways. And we import it to the image, which we use this one.
Web dev, yeah.
And you launch the image, and then your image should look like this, and it would be running. And now I want to access this through X2Go, so remotely, so you guys can do your streaming and everything you want. X2Go, they suggested these. For you to be able to use it and see a graphical user interface, you have to download a desktop environment for X2Go. And basically, they have a couple specified here. As you can see, the XFCE, which looks like this, the LXDE, which looks like this, and then the Made Desktop, which we have chosen to use, which looks like this. And we can download all of them at the same time, and we can SSH to whatever desktop we like. So if you guys don't like this, you want something else, I can download it, and it's just the same exact method, but you will just get the different graphical user interface. So yeah.
Can you access the instance here on the TeamViewer?
Yeah. So that's the instance, and we write password. We're inside the instance.
Right, great. which is our conventional Linux.
Yeah, so this is the instance that you guys will SSH to, and if we go in the, I've already installed inside the instance X2Go server. So for you to access, you need the client. So the client, I've installed it on the Raspberry Pi. You come.
So how easy is it to install X2Go on the Raspberry Pi?
It's just one command line.
Is it?
Yeah.
You need to
it's
give that
sudo
to me.
to get install X2Go.
Oh,
client.
really?
Yeah.
Wow.
So I come here, it asks me for the session name. You can call it anything. So we can call it open stack test4, because we called it test4 there, instance.
Then this has allowed students to work on remote driving applications like this one. Here you can see a vehicle being remotely driven and turning the corner. And here you can see Narinder setting it all up on his software to control the steering wheel. And when he gets going, he starts steering it. And there he goes. And you can see here on the screen the forward view and the reverse view from the cameras on the autonomous vehicle. And right at the end, I do say, yeah, he passed his driving test. so that's going on, and it's quite useful because you can think of all sorts of applications that can come from that. What's next? The next one is, yeah, here. And so this is Tarandeep's project, who was the guy who's actually knocking on the door. And here you can see remotely controlled phone, viewing.
John, your mic's gone a bit funny. We can't quite hear you.
And
John, your sound is just interrupted. Can you probably get closer to the microphone?
sorry.
Yeah, that's much better now.
You can see here the characters A2, B3, which has been recognised from the actual characters on the wall. So there is a bit of background noise from the video from the drone. So that's quite useful because you can think about all sorts of applications like that. You can think of the drone flying off to a flower pot or a pot with the plant on it, and the plot it tells you which plant you're looking at, and then you can then do measurements based on what you know you're looking at. So here's a second system here, but instead of using characters, we're using QR codes to recognize the position of the drone, or the drone recognize the position of whatever the QR code is representing. So that's going on there. Yes, and here's a project now with a student who's looking at this is a view from his employer in Nigeria, and they're flying a drone up in the air and looking at people and other objects on the scene. So that's the first step of his project, and then the second step of the project is to look to see what is the sort of behavior of the movement of the objects of the people in the scene, in order to try to recognize as anything suspicious. Because what's the problem they're having is they've got terrorists near oil infrastructure that are damaging the oil pipelines, and what they would like to do is to distinguish between the terrorists and the ordinary farmer who's perhaps grazing his cattle, so that they can apprehend the terrorists before they destroy the valuable equipment. So that's that project going on. This is a project here from Yifan Lee, and what he's doing is something similar in the sense that he's trying to recognize dangerous situations. So he's created this 3D world and created instances where you can see here, this is a very classical situation where the high-sided vehicle blocks the view of this vehicle here, and so he's driving into a space where he doesn't not know what's on the other side of that vehicle, which could be anything. And so if you don't drive with care, you're likely to result in an accident. So that's what he's trying to do. He's trying to recognize these like dangerous situations to warn the driver to be careful. Then there's another project here with Jeffrey, and he's taking isotropic transmissions and using the isotropic transmissions and using the impulse response of the transmission, which is nothing but the reflections of the different buildings, as, if you like, a signature to determine where the location of the equipment is, and so that he can steer the beam towards the beam at the radio access network towards the user equipment. And because this is like a millimeter wave transmission, where there is like a binary channel, if you step in front of it, it blocks the transmission. There are other transmissions, perhaps via reflectors to the user equipment, so that if you like, we create a man-made multipath environment, and that is also taught within this digital environment. This uses Site Viewer in MATLAB, which is okay, but we're moving on to use WinProp, which is a better simulation tool of a radio environment, a more accurate one. And so we've written a paper related to the Site Viewer system, and we're now writing another paper related to the a factory environment, similar sort of system. So here's another project related to using Copernicus data. Copernicus is a database, a European Union database that provides all sorts of map information, and the student has accessed this map information, projected it, and then taken if you like, OpenStreetMap data, harmonized the coordinate systems between the two so that they align properly, which there was a problem that we had in the first project. Then predicts where to locate a transmitter so that we have the coverage over the part of the here's the target area here, this island here, which we're trying to get coverage on to. So in order to be able to fly drones to it, in order to, say, for example, deliver medicines and small items of food and things like that. So this is a project that has many different applications. The one I've just explained to you is for delivering medicines and food, but it can be all sorts of other applications. Like the one I'm particularly interested in is observing the location of wildfires in rural areas where there's no 5G coverage. And so this is important because very frequently in Southern Europe, particularly in the country I go to for a holiday every year, there are wildfires, really, really serious ones that kill people, many people sometimes, and there's a necessity for creating systems that are able to predict their behavior in order to fight them more effectively. So that's that one going on there. Okay, so then we are also, I just slipped this one in. It's reinforcement learning for the prediction of the channel quality and modulation scheme, and we are trying to remove the signaling required for controlling the channel quality, the modulation and encoding scheme from the channel quality indicator signaling, so that the user terminals can learn for itself how to what modulation encoding scheme would be suitable for transmission. And then finally, this is the new proposal that I've submitted, 6G Dart. So this is meeting, if you like, creating IoT points in a factory, for example, which allows us communicate to access points here via a cell-free network, and via also these intelligent reflective surfaces to get back to the backhaul gateway, and also to use because we're using frequencies that are very high, frequencies that are often used with as frequencies for radar. We can use the same frequencies for communicating as we can for sensing. So the idea is to build the electronic components for doing the sensing of the environment to test to see if people are in the vicinity of, for example, robot and stuff like that. And so we know that this will be some form of radar system which sends out a pulse and receives the echo from it. So this is typical of like a LiDAR system. So the LiDAR system that we've started to access the data from the LiDAR to a Raspberry Pi, our workhorse, very quickly becoming a workhorse to create this point cloud information here. And here on each of these LiDARs is an IMU. So this shows how the IMU is working. So here's the same setup, but if we move an X, Y, and Z, it also gets picked up by the IMU. So this is the X, Y, and Z part of the test, and this is the rho, theta, and phi part of the test. So we rotate it in the different axes. We can move it planar in those two directions. Oh, this is the X, Y, and Z one. This is the X, Y, and Z one. This is the rho, theta, and phi one. Sorry, got it wrong. So this is X, Y, and Z, and you can see it changing up there. And this is the rho, theta, and phi. This is the rho, theta, and phi. So yeah, so you can see here Ben rotating it, I believe. Yeah, rotating it in one direction, then in the other direction, and then in that way, rho, theta, and then finally phi, wherever that is. So that will, if you like, it's like preparing for this new project that we submitted. Oops, sorry, up here. Where is it? Yeah, this new project here, because we're expecting to receive similar sort of data from the sensors that we're building from the communication network, if you like, because they're using a similar sort of modulation scheme, something like that. Finished. Sorry, did it go on for too long? There you go. That's it.
Well, thanks. Questions? Are you ready for them?
Yes, I'm all ready for anything.
Okay. To what extent do you expect the effect of shadowing to affect the propagation of light in your ROL technology?
Yes, that's right. Yes, that's the step up. Each step is a very hard one step. So the at the moment we're only considering a direct line of sight. And if we can measure that, which is hard enough, because we have to measure to the nearest 30 picoseconds. Once we've done that, we can then move on to the next things like moving. This is for stationary points, moving to moving points, moving to points that are moving out in and out of shadow. It's a rich field, so hopefully there'll be a steady stream of students.
Yeah,
work on it. Yep.
Very good. Any questions from colleagues on the floor? Questions or comments, observations to John, or indeed any of the teams who've presented before? I see Tatiana is still around.
Yes, I get the graveyard shift, I think they call it.
I would say, John, great projects. Well done.
Yes.
It's really enjoying seeing what you've been doing.
I think we should try as much as we can to introduce novelty as much as we can. There's no point showing what other industries have developed because they developed them. It's not ours. We should try and if, you know, and you're doing the same. That's why I was so pleased to see your AI lab and all the different, you know, however modest these, you know, these projects are. You know, as I explained to you, from great oaks from small acorns do great oaks grow. That's my what I learned at school. And yeah, so it's important to make even small steps towards trying to create novel solutions. Yes.
Thank you, John. I think it was very pleasure to hear all your exploration, what's going on.
I think we pleased each other with both of our, you know, with we're on the right track. That's the most important thing. But we're on the right track to doing a good thing. You know, my wish is to get a 5G network in Tower B. I think it's 206. And once we get and I've got like entry level network that I'm targeting, that this Israeli company is also if you like selling. And once we got that, we can then transfer the wireless LAN versions of our applications onto the 5G onto 5G networks to see just how much more throughput we do get, just how much more, because that's all their boasts, isn't it? So if that's their boasts, that's what we should expect to be able to measure: greater throughput, greater location accuracy, and much lower latencies. And with that, we can start you know, looking at a whole range of new applications that can exploit these sort of things. The first one I thought of is, as I explained to you, the detection of the position of mines that exists. You know, places like Syria, Afghanistan, and now, God forbid, in Europe, in Ukraine. It's going to kill a lot of people if we can do something to automate the detection of these mines. Would have done something hopefully useful. let's hope that the reviewers see the same way and fund us the money. That's my wish, but if not, we'll continue with the. I've got a little team of MSc students starting to build a prototype of it, so that by the time we start the project, it'll be almost completely built. So through this MSc group. So.
Okay, Tatiana and John, do you have final remarks to address, just as a concluding remarks from the day? To find
Yes, I did like Tatiana's demo. I did like her demo. It was a very useful one, like IoT sensors in industry. So
okay.
I didn't make any comments, but I recognize a good piece of work. Well done.
Okay, thanks, John. Tatiana, any concluding remark or vision with respect to the way forward in your center?
I think we have quite a lot of potentials, and today you saw only one live demo out of all our demos we have ready. Unfortunately, our AI lab at the moment is packed away because of construction work carried out, and the exploration of our technologies applied AI in industrial environments is quite wide, so it's not limited only to the test rig which we have found.
We've seen it live anyway on the AI lab premises the other day, so this was good to see.
Correct.
Yeah.
So I think like sort of we just started to get back from COVID, opening up our experiences. I know that John is really strong with EU funding coming up. We are focusing on completely different strands of fundings, but a lot of potential of technology is being used in IoT and industrial environment with our AI approaches. Like currently, we are emerging quite a lot of ideas into reducing computational efforts and reducing amount of data used without losing the quality of neural networks being trained. So, and these will be deployed in different applications and demonstrating that theoretical backgrounds comes together with engineering labs and ideas, and we're basically closing the gaps in Brunel here.
Indeed, yeah. I think what would be really important from EU perspective, and this is what John is doing anyway, is now that 6G is in the research and development stage, that we make sure we don't miss the train. We've got until 2030 when it is really anticipated it will roll out. And a lot of focus in the research program of the Horizon Europe is on 6G projects, and this is what John is doing at the moment. So thanks very much, guys. Thank you. Also, I extend my gratitude to, of course, other research center directors who have participated to various activities of the day, but also the open day of the Institute last week. Many thanks, of course, to the big champion of the festival, Seb, for all the great work he's been doing behind the scene mostly. And thanks for everybody for your attendance here. Enjoy the rest of the festival. And there will be more to tell you about the Institute going forward. Lots of new things and achievements and findings, which we'd love to share with you in due course. So thanks very much. Enjoy the rest of the festival.
Thank you, Abdul.
Bye-bye now.
Bye-bye.